So what we've done in this tutorial is create the overall form that we can change using the initial sliders. We can also change the width and the location where that is intersected. We also created the glass enclosure, and this is one of the most useful exercises that you can learn when you're fairly new. This will show you intersecting geometry and subtracting and creating straightforward and practical forms that you can use for your designs. First thing we'll do is start with a new file. So I have this in feet in a new Grasshopper file. And I'll start by going to a construct point so I can create a parametric point that I can move, then route it through a point component so I can always change the location of that script. And then we can start here by creating a rectangle. We'll use this point as the plane input, and now we can give two values to the X and Y for the building size. I'll go here to 35 and create a copy by tapping on Alt as I scoot the slider over, and it'll create a copy. So now we can change the building size depending on what parameters we want to use. Next is creating the building form. So what we'll do is create a surface. So we'll go here to boundary surfaces, which will create a surface around that polyline. And now we can use this to extrude. So we'll double click, extrude. We'll use the surface as our base input. In the direction, we'll use unit Z. By default, when you bring in a unit Z, it's going to have a factor of 1. So now let's give it a different value for the height. I'll just go to 25. So this is a parametric box that is our base geometry, starting with our base point, creating a rectangle, then turning that into a surface, which is then extruded. We can always come back to this initial step to extract more information and to continue creating the rest of the form. So what we'll be doing next is creating a subtraction to this overall box. The next step is going to be to create another box that's intersecting, and there are different ways we can achieve this, but the most accurate way of doing it is to actually use, instead of scaling this form and subtracting from it, we'll be recreating a form like this to intersect it. And let me show you how. So we have this rectangle. We can copy this again down here. So now we've created two rectangles, but one of them is going to be, let's say the X size is going to change, but the Y size is going to be the same. So we can use the same slider to tie the overall length, but now we have a different slider to determine the subtracting portion. So we'll take this rectangle and do the same thing. We'll create a boundary surface. This way, when we extrude it, it'll extrude as a solid. And we can take this and move it up, because if we extrude this up, then it will leave a void from the bottom to the top, which could be something that, let's start by doing that. Let me show you. So first thing is we'll copy this, right? Because this is an extrusion and we want to extrude this one, but maybe not by as much as 25. So I'll slide this down, tap Alt to create a copy, and now I can use the new input to extrude that. Now what happens is we have two different sliders, so I can decrease this, and we can also increase that if we want. So now we have two forms that are fully parametric and we can subtract from each other. So I'll go here to solid difference, and I'll create the overall form and subtract. So with solid difference, which is similar to Boolean difference, you'll have A and B. A is what you want to keep and B is what you want to subtract. So what we'll do is we'll plug in A, which is our overall form, and then B to subtract from. Now we can disable the preview on the subtraction and the overall form to see what we have left over. Now what we see at the bottom is the original plane, and the other original plane. So now you're able to see how simple it can be to create intersecting forms. And if we want this y value to be less, well, first of all, it's tied parametrically this way, but if we didn't want it to be as much, we can have it be less. For this exercise, I actually want the 37 and this one to be the same. And this is the only thing that will change. So the overall depth. And here we have the extrusion. Now what I wanted to do and what I wanted to show you is rather than having it have the cutout at the bottom, well, I want it to have a cutout in the center. So this is where we'll go to move. And we can move this extrusion up. So I'll copy this vector and we can move this up. Now this is by too much, so we'll lower the maximum by double clicking here on the slider. And now here we can change it to, let's say 5, because we don't want too much. And then we can have the range of numbers to be the number of points or decimal points is 2. Now we can move this up and down, and we can override the step before, which was static, with this one. So now we can disable the preview, and we can move and shift this up and down to create that form. So this is 5 feet up. We'll just make this like 2 feet at the bottom, and we can change the heights here. So for the next steps, we're going to be turning this into an interior space. At the moment, we have the overall form, so this is what's going to look like from the outside, but we don't have the available space on the inside. So that's what we'll be doing in the next steps. So now what we can do is take that original rectangle, we're going to offset it. And plug in the rectangle into the offset component. Now the distance, since it's going to the outside, will be creating a negative component, or you can also create a negative slider, but I actually like using positive numbers for offsets because that will determine the wall thickness, and the wall thickness you wouldn't want like a -5 or -6. So here we'll go to 2.50 to 2.5 feet, and we'll actually bring this down to 0.5. This then can go into the distance, and we can change this, back to 2 or whatever. Now we've created this inside offset that's going to determine the wall depth. So with this, we're going to now move it up to this location. So we'll go to move. Or first, actually no, we'll do that. We'll move this first because we can move this polyline or the surface after the fact. But I think moving this polyline up will be useful because we can use that when it's sitting at the right location. So we'll move this up by the same vector as the base. This way, when I change the base location, it'll actually change the polyline as well. Next is turning that into a surface. So I'll go here to boundary surfaces. And this will be extruded up. So we'll go to extrude. In which direction? The Z direction. By how much? Well, this is going to have to be the same as the ceiling here. So we will have to extrude that by the same amount. So I could either create a vector or reuse the vector that we have at the bottom. So now we have another form that's intersecting that now we can determine how deep the walls are going to be. And now the space on the inside here will be usable. So what we'll do is take this overall form, go to solid difference, and take VReps A, which is the form that I want to keep, and subtract this new form that I just created. So now when we create a new step that overrides our previous design, then we disable the preview on everything except for what we have here at the end. And you see that we now have not only the form, but we also have this space on the inside that can be used. And as we go along, we see that we're able to shift where that is located and also change the offset like so. We'll disable the preview on the base one, then we moved it up. And now we're going to be creating the glass that goes around. So I want you to visualize that with this, we want to offset halfway or whatever amount from the outside, and then create another surface that then we'll use to create a glass enclosure for this. So this is what's going to show you the power of parametric design. You don't have to use it for crazy architecture all the time. I typically see those exercises and they're really useful for specific scenarios, but in my opinion, this is what parametric design is really useful for, is to create almost simple forms and simple geometries that you can change with the sliders, and it's going to be 100% accurate and will be easy, or it'll be more practical to construct in the real world. So with that being said, let's move on to that next part. We'll move this down, take this. Now we'll be offsetting this, but remember, when we offset the curve, it keeps offsetting it to the outside, which is good because at this point we've offset it in, we want to offset it out, but we want to either do half of this or a different slider. So if you want it exactly in the middle, we would do divide by 2, but we could also just do a whatever slider. You can just say 2.5 and just make sure that it's, 0.56 inches here. And we're going to do this again, offset it to the outside. So how do we do that? We have this offset. We'll just copy it again. So slide it, tap Alt, and re-offset the curve that you had already offset again, but this time using this slider. So this is going to be the glass. So between these two is going to be the glass. So this is going to be the glass depth. So I change that to 2 decimal points so I can slide this down a little bit, and also change the maximum number, let's say to something like 1, so we can come back and adjust it like this. So let's go to boundary surfaces. So I'll double click, boundary surfaces, and what this will do is create a surface between these two. There are 2 ways to do this. We can also loft it, but I've found out that when we do boundary surfaces and we plug both of them in, you get overlapping, but if you flatten it, it actually gives you the surface right in between. So what we could do is take this and extrude it up to the top. But here are the things that go through my mind. There are 2 ways of doing this. We can take this and extrude it up and then subtract it, or we can come back here and see the, go back to this one. We can also move this up, and where this surface intersects with that, we can keep, but I feel like that will just cause a little bit, just more issues. So what I'll do is I'll take this, and let's see if solid difference works with this. I'm not really sure about this one. So I'll go to solid difference between this surface and subtract the overall form. Yeah, it didn't work. I was thinking it might give me half of it, but it doesn't. So the way to do this is we'll take this and we will extrude it up by the same amount as this. So if we see here that this is extruded by whatever amount, we can technically double click here, get a relay, which means that we can add another output here. So we'll go to extrude, which we could have copied. We're going to plug this surface into the base and this relay into the Z direction or into the direction. Now we can take this and subtract it from the form. So I'll go here to difference. I can also, just letting you know the different ways, I can also move this up, which it was, and do intersection. So where this intersects with this, I want to keep or subtract the form from this. So I'm going to actually do an intersect. Solid intersection between this and what I want to keep is this one. So I'll disable the preview on that entire glass, and then we'll take this and disable preview. Now we have the glass enclosure, the overall form with the space on the inside. So we'll take these two, and let me adjust this one. I want to show you. Okay. Now we'll take this and this, middle click, bake. And we've basically created this form that we can go to flipping plane, vertical, and basically created this form that has corresponding ground plane. Here there's a line, we can get rid of that. But the outside, it's going to look clean, and we can change the size of this just with the slider. So that is, in my opinion, the power of parametric design. We can continue on with this design, but I want to just share this exercise for those of you who are fairly new and just getting into parametric design. So hopefully you found this interesting. I will be sharing this on my website, capettidavid.com. So if you have any questions, let me know in the comments below. And I post videos like these every week, so stay tuned for more. Thank you very much for being here, and I hope to see you on the next one. At this point, we've created the overall form, and we can definitely go through and take this and fully develop it using, surface subdivisions and a few more details. But this is the conclusion of what I wanted to show for the most part. Here is one additional thing that I noticed that I wanted to make sure you know, is when you do a Boolean difference, there are instances in which you would create a crease that you don't want. Let me show you that. So I'll disable the preview here, and when I select this, you'll notice that there is this line here, and that line is determined by when we subtracted the overall form. We also have that here in the ceiling. So what we could do is take this and run it through a component called merge all coplanar faces, and this way the new form is not going to have those creases. So what we've done in this tutorial is create the overall form that we can change using the initial sliders. We can also change the width and the location where that is intersected. We also created the glass enclosure, and this is one of the most useful exercises that you can learn when you're fairly new. This will show you intersecting geometry and subtracting and creating straightforward and practical forms that you can use for your designs. So hopefully you find this interesting, and I hope to see you on the next one.